Thank you, Yusuf. All right, it is my pleasure to begin the AI in healthcare panel. We have two amazing gentlemen to my left here, and both of them have very unique research backgrounds that bridge the worlds of AI and health. I'm going to first introduce Dr. Senan, and he has a PhD in computational neuroscience. He did research focusing on machine learning of seizure prediction. So this is an interesting space, obviously bridging the worlds of AI and healthcare. He's also the founder of Hikma Health, an organization dedicated to end-to-end service for Syrian refugees, healthcare, and again, bringing his interdisciplinary skill set to treatment of a group in need. We also have Dr. Ismail here, who did his PhD in biochem and molecular physics with a focus in his research on biotechnology, biosensors, testing protein generation for neurodegenerative diseases like Alzheimer's. He last year was recognized as a rising star in biomedical research by MIT, and he is currently a postdoctoral fellow at NYU. I'm going to honestly, the introductions alone were a little overwhelming for me because we've got some obviously incredible talent here. I want to start the discussion by having Dr. Senan and Dr. Ismail just talk a little bit about their own personal backgrounds, why they chose their research, and what their research is about. Dr. Senan.
Thank you, Ahmed. It's a privilege and a pleasure to be here. So I want to start today by asking everyone a question, which is, to whom does the data revolution in healthcare belong? Right, it's happening all around us. Some of you might already see it. Some of you might use One Medical, might use some of these telemedicine apps. It's happening here, right? It's part of this fourth revolution in health, this fourth industrial revolution that Yusuf was mentioning. But to whom does it really belong? Does it belong to the guys in Silicon Valley? Does it belong to the folks in DC? So I have three answers. I have three folks that I've met that I can share with you that I hope the data revolution in healthcare will belong. The first is Hisham. He's a 7-year-old Syrian refugee boy living in Jordan, and he has type 1 diabetes. He nearly died from a diabetic crisis. So his parents didn't even know that he had diabetes. Neither did his doctors. He keeps coming in with constitutional symptoms, night sweats, and so on. And we got lucky in this case, right? They were able to save him in the ER, but it shouldn't have even gotten that far. So it's kids like Hisham who would really benefit from a data system that if the doctors only knew when he showed up that someone, maybe 5 years ago, diagnosed him as type 1 diabetes, they would have known that what he indeed needed was insulin. Second person who my brother Hassan and I actually met when we were in Lebanon is a lady approximately in her 70s. We'll call her Hajje, which just means let's like honorific. And Hajje was like, we said, yeah, Hajje, we're trying to learn about diabetes and how refugee folks manage their healthcare. So she had type 2 diabetes and had kind of had it her whole life. And we asked her, so what do you think that means, having type 2 diabetes? You know, what's a good glucose level and what do you think might happen? And she said, oh, well, you know, I know that it's really bad if I get to between 200 and 250, I can get retinopathy, and I can get nephropathy, and I was like, oh my God, like this, she could have taught me in medical school, right? I was very impressed. So we asked her, well, Hajji, how do you know all this? And she said, well, you guys never heard of Ammo Google? That's Uncle Google. He doesn't lie. So it was amazing to see, right, that it doesn't matter where you are in the world, it doesn't matter your socioeconomic status. Indeed, just with the click of a phone, you can access that information as long as you have an internet connection. And the last person I'll share with you is a young man named Majid, who is also a refugee. He now lives in Greece. And he managed to cross across the Mediterranean Sea, arrived in Lesbos, and now he's able to share his story with the world. He's an athlete, he's training, he works with an amazing NGO called Yoga and Sport for Refugees, and he actually just won his first race last weekend. So, you know, there's a lot of folks all around the world, highly mobile folks, sometimes refugees, living in different states of health. And these are people who, we like someone was mentioning on the earlier panel, right? We like to think of, oh, they're sick, they really need our help, but it doesn't matter what state of health they are. There are folks to whom this data revolution also belongs. It doesn't just belong at Harvard and MIT, it doesn't just belong in Silicon Valley, it belongs right here with all of us and the people we meet and serve. So there's 70 million refugees all around the world today, and the way things are going, unfortunately, if you include the victims of climate disasters, which are now in effect, at least at some level, man-made, it's going to be 200 million in a few years. And we are, at Hikma Health, the organization that I founded, we are aiming to create a digital health solution that's going to work for all of these millions of displaced people. My family actually originated in Syria, and my own grandmother was displaced by the Syrian civil war. And that, to me, made it personal, but seeing all these other folks and hearing all of their stories moved me to found Hikma Health. And my research was largely on seizure prediction in epilepsy, which is a very niche use case of machine learning. That, if you have a lot of really complicated, machinery to basically record the brain signals, you can then use the software that I developed. But I got to thinking, well, why can't we just, basically anyone with a mobile phone, right? It doesn't matter now if they have an iPhone, $1,000, I don't even know how much now, an Android that costs $100, right? If we build the software and meet them where they are, right? Build the software that meets their needs, and if a doctor's only spending 3 minutes with a patient, which is indeed what we see in Jordan and Lebanon, then we can't build the same kind of EHR systems, the electronic health record systems that your doctors might use, right? Where they're sitting there for 20 minutes barely looking at you, right? We need to come up with a solution that captures the essential information, will help them triage their patients, will help them know the appropriate diagnoses for chronic care, and will interface with the hardware, the diagnostic and treatment modalities that they actually have available there. So that was how Hikma Health was born. And we are basically partnering with clinical NGOs around the world to bring our health data software that we've built to populations that are highly mobile, low resource, and very much in need of chronic care management. And you might think of those as being, the developing world, but literally in this country, right, we have a diabetes crisis. And in Native Americans, it's 16% of the population, right? And you've got folks at the border who have no health care whatsoever. So literally there's not a place on earth that this digital health revolution wouldn't make a huge difference. But what's really exciting to me is that we can leapfrog here, right? Even there's folks where their data is being collected on paper and lost literally to the wind. And there we have an opportunity to institute a digital health system that includes predictive analytics. So we can tell them, not only does Hisham have diabetes, this is what his glucose level is today, and this is where we predict it goes. And if you give him the right glipizide and glyburide and whatnots, he'll get into the safe zone. That's what's really exciting to me, that we might actually be able to institute the very first application of machine learning in healthcare that actually helps real patients on wide scale. We've actually already developed a vaccine predictor that performs at a level where you could actually use it in the field and say, these are the folks that are at risk for not actually coming in to finish their vaccine schedule. So thank you. We're really excited to democratize the revolution in digital health, and it's a pleasure to be up here with such talented folks as well.
Thank you, Dr. Senan. Dr. Ismail, you similarly have an amazing background bridging, again, tech and AI and healthcare. Could you talk to us about your research and what you're doing now?
All right, so I got interested in pathology just by taking a first-year medical classes, and I was interested in how disease develops. And so I started out a year later in the PhD program, kind of left medical school and thinking more about the science part behind these pathologies. And one thing that was clear is that if you look at it just from like the molecular level, you don't know what's going on. So if you want to develop prevention or assays to track these pathologies, you have to get down into the details. And getting into the details, you have to generate tons of data. So I'll give you an example of some of the work that I did in grad school and then what I'm doing today in this regard. So we were looking at the proteins that are involved in Alzheimer's. We're a growing population that is living longer than ever. So a lot more of the population will experience Alzheimer's, or other forms of dementia, right? So we have to figure out ways to prevent that, ways to treat it, ways so that all of us live higher quality lives as we become older. So one of the main problems with Alzheimer's is that it's a disease where you have aggregation of proteins in your brain, right? And it reaches a critical mass and there's no way going back, right? So what we wanted to look at is, what is that mechanism of how it gets there from the start to the finish? So in order to do that, we looked at these proteins in test tube, and we put on them biosensors where we can track these different movements, ensembles of these proteins, and as they aggregate and become the full form-fledged Alzheimer fibrils and tangles, right? And in doing so, we've published tons of data about this in a lot of other groups that showed that there's a diverse, ways of these proteins getting there, right? So now we have not just a bunch of data, but it's all different for different populations of people, right? So now we have to address, okay, where's the best way to start? What is the commonalities between these diverse pools of data for the same disease, right? So we looked at, prevention, so there's this thing called nucleation, the start of this protein aggregation, right? So we looked at that, we generated tons of data, we used machine learning to look at how these structures form, and then that helped our chemist friends design small drugs that target that early stage of Alzheimer's. And then it's also helping other scientists develop assays by taking blood tests to eventually find some of these diseases, screen for some of these diseases early, so that they can give you some of these some of the drugs that are developed for prevention. I mean, we want to get there, but it takes a pool of talent and diverse perspectives from different fields of science to actually get there. Currently, right now, what I'm working on is the role of different neuropeptides in social behavior. As humans, not just humans, animals are highly social, and it's required for us to live in our everyday world. The direct problem that I'm looking at is maternal behavior. So that's like, how does a mother interact with its offspring? Detrimental impact to this interaction can have major implications on a child's growth. So for example, if the child is experiencing neglect, there's many outcomes that they can have: sociological disorders, and also it can exacerbate like autism spectrum disorders. And so we're looking at that. And how we have to do that is you have to look at neural networks, neurons. There's like 86 billion, at least that's what they say, but there's probably a lot more. 86 billion neurons that are talking with each other at any given time to bring forth a specific behavior. And so what we're using molecular assays that we develop in the lab, right? Ways to track these neurons, how they talk with each other, work with computer scientists, right? And develop models of how they're talking to each other, and figure out what are the mechanisms. So can we develop a drug, or can we enhance a specific gene, to fill gaps in these pathologies, to bring back normal function. And so that's what I work on.
Something interesting about both of your comments is that each of you uses your own research in such drastically different ways. What I'm noticing is that, Dr. Ismail, your work focuses on creating an end product that's most likely going to be used by other scientists, whereas your end work is very patient-centric. How do you see that artificial intelligence could help you to, basically, in your case, Dr. Senan, help you to collect data and interpret it meaningfully so that you can give patients better treatment? And in your case, Dr. Ismail, I'm going to follow up with, how do you collect data and how do you use it to better the results you find so that you could deliver your findings to other scientists?
Great, thank you, Ahmed. Yeah, I think this is a really salient point for anyone developing technology of any kind. Software, hardware, railroads, doesn't matter, right? Who's your user, right? And in our case, right now, it's mostly physicians delivering the care to the refugees, but what we're most excited about in our next app that we're currently developing is direct to patient. And that actually has a significant educational and social component, because you think if you're treating Hajj versus Hisham, who's 7 years old, versus Majid, who's a healthy 25-year-old guy, how is that different? And how can you make an app that suits all of their health needs? How do you display their own health data, their own health story to them in a way that makes sense? And on the other hand, and this is probably what Dr. Ismail will talk a little bit about, how do you present the data to key decision makers, whether that's at the NGO level or within the government, or academic leads in, who are looking for epidemiologic data, or even, if you're doing drug development in Alzheimer's, and like Dr. Ismail said, if you have a relatively homogeneous population that you're looking at, various proteins in, you want to make sure you have a wide swath of not just our population in this country, but worldwide, so that when you develop the right drugs, you're targeting something that's applicable for everybody. So what's really exciting about Hikma is we have a simultaneous challenge, but also opportunity, where direct to patient, right, that's one of the most challenging user experiences anyone can try to provide, and we're tackling that head on right now. But we also, once we aggregate potentially millions of data points from all of these people, integrating them in a way that respects their anonymity and autonomy and ownership of that data, but synthesizing all of that data to come up with insights. If you just try to search right now, what is the prevalence of diabetes in the Syrian refugee population in Jordan? There's no number. No one knows, right? Someone walked around and did a survey in 2013, but nobody really knows. So this digital health system will offer us the ability to both reach patients where they are, and that's a very challenging user experience process that we have to do a lot of direct user testing. So we A/B test, we actually develop 2 different systems. We say, hey, which one do you like better? What do you like about this one? And that's a very long, involved process that ultimately pays dividends with people actually saying this is a joy to use, which is not something you hear doctors usually say about their computers. And that's something we're very proud of. But on the other hand, on Dr. Ismail's end of things, when you have the large data set, there's another challenge, which is how do you present that and analyze that in a meaningful, unbiased, and scalable way, right? You want something that's going to validate when you take it to a new population or a new setting.
Yeah, so I'll just give you an example. From in our lab, we generate in a week, several terabytes of data. This is whether it's like a biomolecular assay, so that's just like using different assays that we develop to like look at, let's say, fluorescence or microscopy or whatever, generating images. But one of the cool things I think that's happening in the lab these days is like we're looking at animal behavior, right? So a lot of times when we want to make inferences about human behavior, we have to simplify things, and we use model organisms, right? That would, display some of the same behaviors that we do. So for example, as I was talking about earlier, maternal, mother and pup interaction or mother and baby interaction, right? Mice do the same thing. So we want to figure out, first of all, what are they doing in nature, right? And so we record them for, many hours, sometimes, weeks, months, right? Who's going to sit there looking at that data? No one, right? At first, people tried to just recruit a bunch of undergrads and let them hand score it or whatever. That's not sustainable, right? The idea is to get sustainable, right? So there are companies out there, there are grad students, postdocs, everybody, teaming together to build, you could say machine learning platforms or even artificial intelligence platforms. There's this one company called Lab Deep Cut. It's a multi-million dollar, they're actually growing rapidly. They develop these platforms that will say, oh, what is this animal doing at this particular time? How long is it doing that for, right? And then when you start to change parameters, let's say giving it a medicine, right? How does that change those behaviors? So you're generating these data sets. You're within those, these platforms, they're generating statistics, right? So yeah, a lot of people argue statistics can, be seen however you want, but they try to stay stringent on this, build at the end spit out to you models that not give you per se the answer, but leads you to new hypotheses for you to rigorously test those, right? And from that generates new questions, and then what we like to do in the lab, at least before we publish something, is we want to test the same thing, make sure that it's happening in multiple different angles. 2 or 3 tests that test the same thing, but in different methods, right? And so then we can take that data, we can publish that in the form of a paper, right? That is shared and disseminated to the community. But then this research, a lot of the research, let's say just for the sake of United States, since we're here, majority of research money comes from the National Institute of Health, right? They have a $40 billion budget, right, per year. And it's increasing every single year, hopefully. But that has been the trend. And so based on the data that was generated, right, they start to restructure their priorities of what is needed to be investigated, right? So for example, at the forefront right now is, in fact, they have an AI and science directive. They also have now something called the BRAIN Initiative. It's one of their biggest endeavors. And then during the Obama-Biden era, which is still going on, they had the Moonshot program, which is to solve cancer, right? So based on all this data generation, they pick priorities, and that's where most of the money is going. So if you look at it based on those priorities, the largest sectors are cancer, neuroscience, right? And then there's a whole new section of health disparities. Now they're looking at diversity because there's a ton of people, as I said before, a lot of diseases, are not the same for all people. There's a lot of heterogeneity, right? And so now that genomics is becoming much cheaper, like anyone can sequence their genome for less than $1,000 now, right? And so if insurance starts to pay for that, which they do cover it for people who are in certain risk populations or whatever, they can now jump into this era of personalized medicine, right? So I think that's the way of displaying this data, and that's a good example of how that impacts your health right away. And I think the most used example of this is in children's hospital, right? Children's hospitals all over the United States and the world, children's of high risk, they will sequence their genome, they will even do proteomics, they'll do metabolomics, whatever, and they will take all this data and say, all right, this is what's wrong with the child, right? And if they can't figure out from that, they'll do further assays. They'll even invent assays to try to do that, to address some of these needs. And not every child is lucky to have that. As we're hearing a lot about refugee camps and less fortunate countries where that's not even a possibility. So, generating this data, perhaps can inform that elsewhere as well.
It sounded like in the middle of your description of your work that you needed someone to come play with puppies, and you're looking for someone to do that. And if so, I'd be glad to help out on weekends.
Get in line.
Yeah. No, it's honestly, in all seriousness, it's amazing the difference in also, I think, focus between you two. You guys each bring such unique perspectives to this discussion. Your research is mainly funded by US dollars.
Huh?
Your research is mainly funded by US dollars.
All of it, yeah.
And I think it has a US-centric focus. We talk about difference in patients, and versus your work seems to focus on a rather specific group of people who are in need of help. I am personally fascinated by the idea of personalized medicine. That you could sequence a human's genome now, whereas that costed $2.7 billion roughly a decade ago. That is fascinating. But with that comes concerns about knowing basically what happens with a patient's data. Can insurance, for example, be affected by someone's genetic predispositions that you will automatically be charged higher insurance? This is the lawyer in me talking, apologies. But also that all that data about someone's entire genetic code, how is it that you think that all these data sets, this intelligence that's built around patient tailored healthcare could be protected in a way that's sufficient to make sure that Hajj doesn't have her business in the streets, in essence, when it comes to her healthcare?
Yeah, this is an absolutely crucial question, and I think in every population, but no more than in a refugee or any vulnerable population. And it's not a theoretical exercise. Sometimes you think, oh, I'll watch this ethical thing on YouTube and whatever. This is real. Right? There's real people whose paper records have been stolen from a friend of ours who's a psychologist's office, right? One of the other practitioners left the papers unlocked, and those paper records were stolen. And then those very refugees whose records, some of them whose records were stolen, they were disappeared the next day. So when you're working in this area where there's malevolent actors, there's a lot of ongoing violence, and the war is ongoing, you know, the last thing that we would want to do is have a leak of any of the data. So data security is absolutely top of mind. And even the way we design the system and distribute the data, like who should be able to see it and when, right? There's a temporal component too. If you're one of these docs who comes in for medical missions, you don't need to be having access all the time. So we are basically designing the system from first principles with security at top of mind. And we've had some folks who volunteered with us that have a lot of deep expertise in this area, and we really appreciate their focus, because frankly, you'd be sitting here in the States thinking, oh, it'd be great to do facial recognition or fingerprint recognition, and then you think through the actual consequences of that, and while the technology is seamless and the doctors would love to make it that easy, you got to think through the potential consequences of the data leak. And the flip side of that is actually thinking about what data should be collected at all, right? Think about, in this setting, we actually have a conflict that's pretty significant between all of the various actors that are at play that want particular data about the people, right? Governments might want data that's actually insalubrious for the people. And you have other NGOs and potentially like pharma companies might want the genomic data, for example. They're very interested in that. But for our actual patient care, there's no way that knowing someone's genome is going to actually impact their care, right? The things we need to know about them if they have diabetes, given limited medications we have, their glucose level, their A1C level, and a few other clinical signs. And that's it, given how much time we have and how the kind of resources we actually have available therapeutically. So we have to think through not just from a data perspective, that once we get the data, what is the appropriate way to handle it in a way that respects the person's autonomy and security, but also think through in the very first place, should we even be collecting that data? Is there any benefit to the patient, or is there even some non-zero security risk for no potential benefit? And that's the cost-benefit analysis that keeps us up at night, and that we're always dynamically thinking through to make sure we're doing right by our patients.
You know, from the perspective here in the United States, there's just a gluttony of data. So there's many companies out there, you know, capitalizing on this in the electric medical record space. So I've done all my research at hospitals. So you have to go through the rigorous trainings of like HIPAA and, you know, EMR compliance and things like that. What I do think about that is that there can be better regulations of like who can see your data and who cannot. So what I mean by that is, for example, I know clinical research coordinators, right? They're curious about a person, they can just look them up as long as they have clearance, right? I don't think that's okay. But on the flip side, you know, generation of that data is actually really useful. Let's say, for example, clinical trials. If you want to, if you want to find a subset of population that's, you know, useful for your specific disease, right? Whenever you generate a clinical trial, you have a protocol, right? And that protocol lists all the inclusion and exclusion criteria, right? Let's say if I wanted to just screen a clinic, right? I have to go to each individual person and ask them, do you meet this age criterion? Do you have, you know, X disease, all right? Are you taking, you know, Y medicine, right? Very tedious, right? But if you know how to use the EMR or electronic medical record system well enough, right? What you can do is you can put your inclusion and exclusion criteria, and you can generate from your entire hospital system, you know, a pool that would fit that criteria and save you a lot of time. And machine learning and AI is being used for this every single day. So I think that's a good example of where that's really useful. So, yeah.
As a follow-up question, and basically the different ways that we see AI developing the medical profession, it's becoming an integral player in basically providing doctors with doctors with data that someone else might have collected, or in literally identifying a patient's health overall and pairing them with a relevant doctor. For me, I'm actually pretty interested in the space of how we see AI supplementing and or replacing physicians as they interact with patients. Do you think that we could have, for example, a doctor totally remotely treat a patient in a conflict zone? Literally just even something like something as complex as surgery, for example, being administered entirely remotely. Do you guys think that that's a possibility in the future? And in the limited space that's happening now, do you see growth in that space due to AI?
I mean, we can, and we have, actually. I think there's a lot of steps that I alluded to this earlier, mostly in the software space, but it's equally true in hardware. I mean, even if you don't, so you can think of, for example, a scenario that we've seen play out where there's, in the city of Aleppo during the siege, there weren't any specialists, right? You'd have like a second-year surgical resident that's the only surgeon for miles, right? And he's responsible now for the catchment area of, containing 500,000 people. He's sitting there trying to do some advanced neurosurgery. So the way that played out is someone Skyped, some bilingual Syrian British person, Skyped in from London, and basically this guy who had basic surgical skills but didn't know anything about neuroanatomy was told how to do whatever he could do. And he did that for name the surgical specialty, and he was able to execute it a pretty decent rate. So that tells you that once you have a robot in place in this kind of setting, I mean, I don't know if that'll ever come to pass, but if it were there, the ethical breach has already happened where, a lot of doctors I won't even give a diagnosis until I see the patient. Well, if the patient's bleeding out and there's no doctor in that city, right? Literally, I met the only female medical provider that was left in that siege, right? And in that cultural context, it's very important for a lot of women. So there were a lot of women that just weren't getting care. So this woman stepped up, this doctor, and she trained several score midwives to basically help her with, births that were uncomplicated. So you see a lot of the creativity and ingenuity, but also a lot of the, what I'd call ethical realism to say, okay, that's all nice for your professional standards, but at the end of the day, when you have limited resources and time, you're gonna do what you gotta do. So it's really interesting to see that, because now you can imagine a setting where there's maybe not even any doctors wanna go, but you get one surgical robot going, and then you get all the different specialists as needed on the joysticks, and it could actually happen. So I think that's a little far in the future, but even today, I alluded to this earlier where the HRs are being mined. It's very true, Dr. Ismail, and there's a lot of offline processing that happens, a lot of offline machine learning that happens, like the stuff that we do, okay, it would be nice to predict seizures. But I've been at Mass General Hospital for the last 3 months, and I'm very fortunate to be there. It's one of the best hospitals. But at the end of the day, there's not a lot of machine learning happening on the wards. You ask them how they even calculate a risk score, and it's literally an algebraic formula that 10 years ago didn't even have a component for if you were a member of a racial or ethnic minority. So it was scores that were calculated from the Framingham Heart Study that was entirely done on white folks, white men. And then you have the Nurses' Health Study, which at least was on women, but not as ethnically diverse as the population we serve today. And Yusuf alluded to this earlier, and I think nowhere is this as pernicious, perhaps in policing, but also in health, where life and death are on the line. Now, you give someone the wrong score, you give them the wrong medication, they're no longer with you a year later. So I think machine learning can have an enormous positive impact if executed correctly in the healthcare space. But frankly, this as a lawyer, Ahmed, the incentives are not aligned, right? We live in a hyper-litigious environment, and a lot of medical professionals and medical organizations, like a large hospital, are really hesitant to rock the boat. So even after we execute for a lot of places, we'll say, well, look, Hikma Health actually has we are HIPAA compliant even, and we have the first integrated predictive health system. It's not very likely that MGH or another big institution is going to jump from Epic, which has been their safe for the last 30 years. But over time, right, and maybe in 10 or 20 years, the conversation will be different, where we're actually banking on the patients being the ones who will come to expect this kind of personalized medicine no matter where they are and what condition they have. They won't accept oh, this is the, they'll see the doctor looking at the algorithm and say, oh, just going down the tree. They're going to say, I want to know my probabilities, right? Talk about my family history and my personal medical history and my diet and my exposures, and tell me which medication I need. And so I think in the future, we'll see that in this country, but we'll see that around the world as well, where patients are actually demanding this level of excellence from their providers. And I think at that point, the physicians are going to step up and say, okay, these tools that have been kind of incubating more in the research space, it's time to bring them to the hospital.
To the practical space, yeah. This is definitely interesting stuff. I mean, I have a slew of other questions that I have here, including brain-computer interfacing, like obviously the play into the regulatory space, privacy space, and the international dynamic. But at this moment, I'm going to stop hogging the mic, and I'm actually going to open it up to the crowd for a little bit of Q&A. I feel like we have obviously incredible people here. Who has any questions for either Dr. Ismail or Dr. Senan? Okay, I saw that hand bolt up first. Please.
Sorry to be hogging the floor.
No.
Just really love the refugee work that you're doing, and in this city it might be a question as to whether we do have climate change happening or not. But one thing that we can't deny is that on the African continent we're going to double our population between now and 2050, another 1 billion people. And this issue of identity that you are grappling with, sort of a twofold question. Have you looked at, and are you looking at self-sovereign identity, blockchain-based decentralized identity, which basically means that you can hold your own data, which is fantastic, but in order to do machine learning, how do you, now that we as self-sovereign identities are holding our data and we only share what we want, how are we going to access that data for machine learning, and which is what the benefit of having a centralized server, but then there's the problem of that being stolen and all of this. Yeah, how are you managing that?
It's an excellent question. I think it's really great to see all the applications of blockchain. We're not one of them, but I think in our case, there's something we did learn from the blockchain revolution, which is the empowerment of folks, and whether that's through decentralization of the actual data itself, which you're alluding to, or it's autonomy of access. So without the pass, like basically the user, right, in our case the patient, is going to be the be-all and end-all of who gets to access their data, which is effectively, as long as we can, and we will actually redundantly store their data on their own device as long as it can be encrypted to our standards. So that is to say, at the end of the day, the principles of the blockchain revolution we very much support, and it just wasn't the right technology for us, given the scale that we're trying to work at and the population that we're working with and the problem that we're trying to solve. But at the end of the day, the principles of, sorry, what was the term you used, sovereign?
Self-sovereign identity.
Thank you, self-sovereign identity. That's absolutely core to what we're trying to do here in terms of giving people control over their own health data. Now, the other side of it, which, as you can tell, I'm also personally very passionate about, which is leveraging machine learning at scale, right? You need millions of people to ultimately opt in and say, or at least hundreds of thousands if you want to use these deep learning models that really perform. And the question of how to incentivize them then to share their data comes up. And with a vulnerable population, right, you might think of, for example, in this country, there's a lot of really cool companies. There's Nebula Genomics from George Church in Boston, and there's Luna out in San Diego. There's a lot of them that say, hey, give us your DNA sample, we'll sequence it for free, and we'll give you $100, or we'll actually give you a small slice of equity in our company. And then with all of that pooled genomic data, they're going to do some really amazing machine learning that's going to help pharma or somebody do something that creates value. Now, when you're dealing with a refugee population, that's not really an option. So we cannot, unfortunately, really offer financial incentives. So that one's out. So then the question is, how do you offer an incentive? So one thing that we've thought of that we're really excited about is actually offering patient-specific models, right? So we'll offer a model to Hisham, but to make a model about Hisham's future, we need data not just about him, but about thousands or hundreds of thousands of other kids with type 1 diabetes. And we'll leverage all of that data to help Hisham and all the other ones. So now the incentive is really, look, if you want to get these really cool predictive tools that are actually going to help you and your doctor with your own health, you've got to opt in and check that box. So the ethical principles are the same, the self-sovereignty is absolutely the same, but at the end of the day, we're using the technology that's exactly right for our solution, and we want to incentivize people in an ethical way to join our machine learning pool.
Thank you. Yep.
Yeah, hi. I thought actually it's a bit technical, although I'm not technical, let's say that again. a lot of people come to us, for example, when we're talking about AI and machine learning, and they assume it's going to replace human intelligence, right? And so when they're trying to use our platform to understand the variables that affect their impact, then one of the first questions would be, would it tell me if I'm missing a variable? And I said, no, the whole concept of AI and machine learning is actually to augment your intelligence, but it will never replace. How do you deal with that in your case? So how do you make sure that you have, that also means collective data that you might think is relevant or doesn't? There's something we call unintended impact, right? So there's sometimes a variable that will affect your outcomes that you haven't necessarily thought about. In microfinance, one of those is the rise in the number of divorces when the woman becomes economically independent, right? We've never thought that this is something that would happen, but she actually would leave an abusive husband because she became financially independent. And we never took her marital status into the variables that we would be actually looking at. And now we do. But how do you deal with that in terms of medical practice?
I don't know, Dr. Corey. It sounds like you might be technical at the end of the day, talking about variables here. So I don't want to nerd out too hard on everyone here, but it's absolutely right. The way that we create what we call features for machine learning, which are basically the variables that we send input into the machine or into the algorithm that's going to predict an output or an outcome for us, right? You're absolutely right that humans are still the very best at that process. Right, where machines excel is at things like pattern recognition. So if you want to send a squiggly trace, like an EEG signal like I was working on, or images that you've taken from your bioassays, right? The machine its eyes don't get tired, right? It doesn't have color blindness. The machine is really good at picking out, this is the exact shape that means you have alpha versus beta protein, or this is the exact one that means an alpha or beta wave. Machines are not great at picking up really subtle variables that might be interacting somehow, like you mentioned with women's empowerment. If a woman is a part of an abusive household and or educated and or has a job, those things might interact in certain ways. And humans are actually really good at, first of all, coming up with those primary variables, saying, I have 10 minutes with this person, what are the key things that I have to extricate from them? And that's actually where physicians also, I believe, will really never be replaced, because that is the last line. That's where humans are always going to be the gold standard, getting the right information out as primary variables. And then where machines are getting better and better is, okay, if I give them that entire 10-minute conversation that I had and let it extract the right features, it's going to get better and better at saying, okay, well, maybe like, intimate partner violence or domestic abuse, those are like issues that maybe we should be looking at. So machines are getting closer and closer, and a lot of these deep learning techniques that we talk about, the reason they excel so much is they're getting better and better at abstracting higher level features or variables. But at the end of the day, I really believe humans as the first line of communication and extraction of variables, that'll never go away.
I thought you cracked it the other way around.
I don't know, to piggyback on that a little bit, I mean, AI is really good at demonstrating processes and making processes better. So for example, I come from also a chemistry background, right? And so there was a paper published like 2 years ago in Nature, which is like the big journal, and so what they showed is that you have the best organic synthesis people who will make molecules. They will come up with one method, right? But these supercomputers, what they do is they have access to every single synthetic route that has ever been published, right? So you can, put your end goal product in there, and they'll find the most cheapest, expedient, route, to make that molecule. So I mean, it improved a process that probably would have taken, a team, a few months, if not years, to do that. So, process.
All right, we're going to do one final question. Here.
Hi. I was wondering if you'd be able to unpack a little more around the ethical realism, like practically in your organization, what frameworks, governance structures, things that you use to guide your decision making and document, and have some sort of record of why you're making ethical decisions in a particular way, practically how you might be doing that or planning to do that as a
Yeah, that's a really important point that we've really wrestled wrestled with this extensively in the last 2 years, and I think a lot of it has come down to seeking guidance from those that have tried it before, because the ethical principles are often clear, like don't lose anybody's data because you don't know what will happen to them. But then in terms of actually trying to execute the kind of project that we are, which is really threading the needle at times, right? Getting the right data to care for the patient and not losing it to put it in the hands of any bad actors turns out really hard. And talking to folks who have worked in the security space, people who've executed data systems for nonprofits and these kind of places. So we have a board of advisors that's highly experienced in this space, and a board of directors that's also totally independent from the management of the organization. And I think that independent oversight, even though we're a young organization, I'm really proud of the way that our leadership has continued to basically put in a lot of time and effort and thought into making those decisions. As to documenting them, I think that's a really great point actually that frankly we haven't done enough of, and we've documented a lot of it internally with like board meetings and reports to the internal members of the organization. And we, at Hikma Health, we really pride ourselves on like financial transparency, so we're going to be releasing what happened with all the money. But I think your point, Dr. Roer, is an excellent one, that we should also document the ethics behind the decisions we've made. And for example, one common question we get is, well, why are you always doing Syrian refugee stuff? You know, there's refugees we get in our inbox now stuff from Haiti all the time, and we're actually talking now to some clinics in Uganda. And the ethics behind our reasoning there, especially with a lot of us being of Syrian origin, it's actually the biggest health crisis and biggest refugee crisis of our time. And it's also where we believe we can make the most difference given how little is being done. Each Syrian refugee has only gotten $1 for every 10 that's gone to the average other crisis, right? And I'm not saying there's an equivalency of need, but clearly there's a scale issue here. So we felt objectively, given our organization, our skills and resources, this is where we can make the most impact to start with. And then we're gonna move into Uganda because we can make a lot of impact there. And with Haiti, like there's obviously people in need there, but does it align? And I think documenting that and explaining it in a way that aligns with our ethical framework for all of our supporters and all of our potential partners is actually a really great suggestion. So thank you.
All right. Thank you to our panelists. I'm going to unfortunately have to pull the plug, but thank you both for coming to speak. This has been an incredible panel, and they will be accessible for the rest of the day, so feel free to please talk with them further on any other questions you guys might have. Thank you. Thank you.
So folks,